Greetings, welcome back to Randomtronic. My name is Chris and today I'm going to melt some solder. As you may have seen before in the previous stuff waiting to be dealt with video, I've opened this up. And it was a mystery package to me because I didn't order it. It was just sent to me. It was addressed to me, came to my address and had my name on the packaging. I really don't know where it came from. Nonetheless, we've deduced that this is likely to be some sort of a remote control. This is the transmitter board. It's battery powered, and here is a receiver board. Thankfully, the silk screen is very descriptive because there aren't any instructions with it. There are a couple of surface mount chips and the rest of it is through hole, so it should be a breeze to put together. And of course, what's more fun than soldering something? This is the bag, I think, because it's got the buttons. This should be the one for the transmitter. 2 angled tactile switches, 4 straight up ones, 2 caps, an angled connector, an LED, crystal oscillator, the surface mount chip, a jumper, switch, ceramic cap, 1 resistor, 4 screws, self-tapping ones, 2 screws with nuts, and 1 spacer, I guess. Oh, we'll figure out where that goes. The chip itself, as you can see, it has got no markings whatsoever, but we have been blessed with a pin 1 indicator, so at least we know which way round to put it on, and that has to go here. So we could solder it in 2 ways. We could either tin the pads and then use the hot air, but I'm gonna try to solder it the conventional way. It's always a good idea to add a little bit of flux. That's about right. Let's add some solder to the tip. Hopefully I don't get out of the camera view. Okay, that's 1 pin soldered. Maybe 2 more on the other side. Okay, that's securely held in place, so now we can do the rest of them quite quickly. I need a bit more flux over here. And just to touch it up. And the other side. Yeah, that's all nice. Let's figure out where's the rest of the components. We've got crystal, 12 megahertz crystal, check, 100 nanofarad, yep. I'm gonna bend the legs just to keep it in the board so it doesn't fall out. 2 electrolytics. From the footprint I'm judging that they should be mounted at an angle like so to keep the board profile lower. Okay, let's quickly clip those leads off. First few components are there. What's next? Tactile switches. So let's put them in. Oh, interesting. How is that supposed to be? Check this out. So this is a bit unusual. So this is the footprint. So we've got the holes for the mechanical retention, but the actual contact switches are here. To get this right, we need to do something like this. So bend the legs backwards, do it like so underneath the board, because I can't see any other way to mount this, so it has to be that way. So we'll do the same to the other one. Kind of guessing the whole thing how to put it together, but it does not look like it's something overcomplicated. It's just a few components. Nonetheless, it's great fun to put together a mystery like that. Who knows what it actually does. That's almost done. JP1, JP2. What? Do I need to jumper this? I presume so. So let's find 2 legs of something. Resistor leg. There should be a resistor somewhere. There it is. That's a 10% resistor. I haven't seen those in a while. 1%. The metal film resistors are so cheap. I didn't think anyone makes those little carbon resistors anymore. Okay, and we salvage those 2 legs for the jumpers. It's a simple PCB. Someone didn't try really hard to avoid having jumpers on the... Quite sure it would be possible. It doesn't look that complicated. Switch, LED and battery. I think this is meant to go that way. I should check really. I'm gonna risk it. because there are those two bigger holes, so normally that's to indicate to push the battery lead through as a form of a strain relief. And the LED, I'm guessing the LED should be in line with the power switch height wise, so yeah, about like so. The body of the switch has got a big thermal mass, so it's kind of tricky to solder. We'll add it, give it a bit more flux, and it should go. There we go, this one did. And now this one did. Just needed a little bit more heat. On off power switches. This I'm guessing should be, oh, that's for the battery here, like this. So we can screw the battery in, and using the screws with little nuts, which are somewhere here, there they are. Okay, I think that's what it's supposed to look like. Excellent, let's see if it fits in the box. Okay, it seems it does. One more item, which is the little pin header and the jumper. How is that supposed to go? Oh, how nice. So there's this cutout which fits around the plastic former that's around the pins. Sitting place for the pin header. When in doubt, always add flux. That always is the problem, not enough flux. So jumper 1 set A to B, will set it to A. Presumably that's just like a channel selection for the communication. So that is now complete. Those little things, no, that's not gonna work this way. We have to put them on first, and then oh, it doesn't want to fit. Come on, come on, come on. Okay, let's try this way again. Okay, this seems to be more annoying than I thought. I knew I was right all along. Perfect. So screw it in with self-tapping screws provided. I'm not sure what this is for. I haven't used it. Maybe I should have. Seems like we've got one part of the puzzle complete. Next, this thing. 4 wires that are not stripped. 3 chips. Another one of those unmarked chips. A transistor switch, some JST sockets, and a capacitor. So let's do the same thing on this one. A little bit of flux and yeah, and get one of the pins. Good. Now the other side. Oh, this one looks funny. Those chips, what are those? LM9110. And of course, as I thought earlier on when I unboxed this, those are H-bridges. H-bridge modules, which will allow the rotation of a motor to be either direction. I'm starting to think, how am I going to test this if it's working? Because I need to connect something on the output. Maybe I could do 2 diodes in parallel, and this way only one will light up depending on which part of the H-bridge is activated. That's an option. This board is through-hole plated, the other one wasn't. On a through-hole plated board it takes quite a bit more solder to get a nice joint, because the solder gets sucked into the hole and fills up the entire through-hole. Seems I'll never get a hang of this soldering on camera thing. So next we have a switch, which I have already soldered up one hole for it. Push that through while heating up, that should solve the problem. There we go, like this. Crystal oscillator, 12 megahertz. I was wondering, why is there this transistor? What is it for? But it's not a transistor, it's actually 7133A. That's a voltage regulator. Okay, this cap, because of the screw and the switch, I'm going to just bodge it at an angle. Soldering videos are in general really difficult to do, at least for me, because I can't talk much, because of my indivisible attention. So when I'm soldering, I'll either talk rubbish or I'll do rubbish soldering. So I tend not to talk. But then quiet videos tend to make boring content. But every time I get something to solder, I get excited about it and I want to make a video with it. And then when I actually do the video, I realize like how difficult it is to do a soldering video. I hope you understand, viewers. And let's cut those off. And we are done. Oh no, we're not. The JST connectors. Do it this way, so the plus can be red. Are they at least all the same? Yeah, it seems so. That's one. Let's do the rest. It's nice that the connectors are the tallest thing on the board, so we can just stand the board on them. Now this is done. And I've even found a motor to test it with. Put a piece of tape so we can see if and when it rotates, either direction. The board says that it will take 3 to 12 volts over here, so we'll give it a 5. That seems like a reasonable voltage. That will be voltage driving the motor, and the motor I just pulled out of some old CD-ROM. I think it's a 5-volt motor, but even if it's a 12-volt motor, it will rotate even at 5. There we go, 5 volts, and let's set the current limit to say 300 milliamps, no more than that. Okay, seems a AAA is the size. I've got a pair of really abused batteries, but they still have charged. Okay, so that's on, and whenever we press something, the light comes on. Good. On the receiver side, let's make it output on. It's drawing 7 milliamps. Check this out, it works. Let's try another channel. So channel 2, I think it will be this one, so should be those. Yeah, both directions, excellent. And channel 3 is this one, a 3-channel remote control with 3 H bridges. That could be put in a little toy car or lots of different applications. Very responsive. It's 70 milliamps with the motor on, 7-8 milliamps in standby state on the receiver side. The transmitter, I am not sure, but presumably not much when it's not transmitting. But yeah, that's about it. So that's the mystery package that was sent to me. We put it together and it works. Surprise! So thank you very much for joining me for a soldering video. I hope it turned out okay after editing. I don't know how it's going to turn out because I haven't edited yet. But anyways, if you have stuck around to hear me at this point, thank you, and please do come back for more. For today, that's it. Take care.